A 30 degrees reducing elbow is shown below. The fluid is water. Evaluate the components of force that must be provided by the adjacent pipes to keep the elbow from moving. Use the gauge pressure PATM equals to 101 kilopascal. From this figure, it's giving us that flow rate is equal to 0.11 meter cube per second. That goes from left to right, and the pressure at 1 is equal to 200 kilopascal in absolute pressure, and A1 is equal to 0.0182 meters squared, and P2 at point 2 right here is equal to 120 kilopascal absolute pressure, and A2 is equal to 0.00821 meters squared. And the mass of the elbow is given that is equal to 10 kilogram, and the internal volume of the fluid, which is water, which is 0.006 meter cube. So for the pressures, we have to convert them to the gauge pressure by subtracting 200 kilopascal from 101. It's gonna give us 99 times 10 to 3 pascal, and the same thing here for P2. So we need to subtract 120 from 101, so multiplying that by 10 to 3, so that gives us 19 times 10 to 3 pascal, and that's in the gauge pressure. So this problem is requiring us to find the forces on the x and y directions to keep the elbow from moving. And in order to solve this problem, we first need to draw the control volume of the pipe. So the control volume gonna look like this, and we have to indicate the normal N, which is always pointing out of the control volume right here, like here and here again, and the pressure, the forces acting on the control volume at point 1, which is P1A1, which is has to be indicated toward the control volume, and the same thing here for point 2, P2A2 has also to be indicated toward the control volume here again. And since the flow rate is pointing from left to right, so V1 has to go from left to right, starting from here, which is V1, and V2 again here, right here, so it has to go from left to right, so it's pointing outside of the control volume. And since like the weight of the water and the weight of the pipe are considered, so the weight of the water and pipe are pointing downward. So to solve this problem, we know that the dP system over dt is equals to delta over delta t times the integral of control volume rho times the vector velocity dv plus the integral of the control system rho times the vector velocity times the dot product of v dot n times dA. Since it's a steady flow, so this term goes to 0, so we will end up with the integral of control system of the velocity of the density times the vector velocity times the dot product of v dot n times dA is equal to the summation of the force content of the control volume. So here is our control volume again, and this is our system. And to find the force on the x direction, so the force on the x direction is equal to rho times positive v1, since it's going to the positive x direction, and since v and n are in the opposite direction, so it's gonna be minus v1 times a1 plus the density rho times, there is here a velocity on the x direction going to the right with an angle of 30 degrees, so it's gonna equal to v2 cosine 30, and since v2 and n are in the same direction, so it's gonna equal to positive v2 times a2, is equal to the forces on the x direction. So there is here a force of P1A, there is here a force that equals to P1A1 that goes to the positive x direction, so it's going to be positive P1A1, and there is here a force that's going to the negative x direction with an angle of 30 degrees, so it's going to equal to minus P2A2 cosine 30 plus Fx, since our system, here it's to the positive x-axis. So by simplifying this, we will get minus rho v1 square a1 plus rho v2 square a2 cosine 30 minus p1 a1 plus p2 a2 cosine 30 is equal to fx. So in this equation, we have two unknowns, v1 and v2. So to find v1 and v2, it's given that the flow rate q is equal to 0.11 meter cube per second. So from that, we know it's that q is equal to a1 v1. So 0.11 meter cube per second is equal to 0.0182 meter square times v1. So from that we'll get v1 is equal to 6.044 meters per second, and the same thing for v2. We know that q is equal to a2 v2, and 0.11 meter square per second is equal to 0.0081 times v2. So from that we'll get v2 is equal to 13.58 meter per second. So by plugging v1 and v2 in this equation, we will get minus 1000 is the density of water times 6.044 square, which is v1 square, times 0.0182, which is a1, plus 1000 times 13.58 square, which is v2 square, times cosine 30, times a2, which is 0.0081 minus P1A1, and by multiplying the P1 gauge by A1, we will get 1801.8 plus P2A2, and P2 here is again the P2 gauge, and by multiplying P2 gauge by A2, we will get 153.9 times cosine 30 is equal to Fx. So from that equation, we'll get that Fx is equal to minus 1040 newtons, or it's equal to 1040 newtons to the left. And to find the force on the y direction, it's going to equal to density rho, and by the way, like here there is no forces on the y direction. So from here, the force in the y direction is going to down, so it's going to equal to minus v2 with an angle of sine 30, so it's going to equal to minus v2 sine 30. Since v2 and n are on the same direction, so v2 dot n is equal to v2 times a2 is equal to the forces on the y direction. So here we have for p2a2, there is a force on the y direction going to up with an angle of 30 degrees, so it's going to equal to P2A2 sin 30. And here we have the way of water and the way of the pipe, so both of them going downwards, so it's going to equal to minus W water minus W pipe plus Fy, since our system pointing to the positive y direction. So from that we will get, by simplifying this equation, we will get minus rho v2 squared sin 30 times a2 minus p2 a2 sin 30 plus the weight of the water, which is equal to gamma times volume. So from our physical properties table, we will get the value of gamma of water, which is 9.80 times 10 to 3 Newton per meter cubed, times the volume, which is given right here, which is 0.006 meter cubed, plus the weight of the pipe, which is mg, so it's given that the mass of the elbow, which is 10 kilogram, times the gravity, which is 9.81, is equal to Fy. So from that, we know that the density of water, which is 1000, so we'll get minus 1000 times V2 square, which is 13.58 square, times A2, which is 0.081, times sine 30, minus P2A2, by multiplying P2 gauge by A2 is equal to, P2 here is the gauge pressure again, so it's going to equal to minus 153.9 sine 30 plus 58.5, which is 9.80 times 10 to 3 times 0.06 gives us this value, plus 9.81 times 10 gives us 98.1, is equal to Fy. So from that we'll get Fy is equal to minus 667 newtons, or 667 newtons to the down.